Hello and welcome to another CS Tutor Center video. Today we're going to talk about the problem Remove Duplicates from Sorted List 2. Before we get started, if you like these videos, please subscribe to the channel. When you subscribe to the channel, it lets me know that you like the videos and you would like me to make more of them. Alright, let's get started. Given the head of a sorted linked list, delete all nodes that have duplicate numbers, leaving only distinct numbers from the original list. Return the linked list sorted as well. So in this example, we have a linked list and we see that there's threes that are duplicate and there's fours that are duplicate. And it wants us to remove all the duplicates. So when we remove all the threes and all the fours, we are left with 1, 2, and 5. Let's look at this example. So they're duplicate ones, so we remove all those ones and we're left with 2 and 3. Let's look at the constraints. The constraints say that we could have no nodes that get passed in, so head could be null. There could be up to 300, and the values between -100 and 100. And the list is guaranteed to be sorted in ascending order. So we'll make use of this fact that it's actually we don't, we don't even have to worry about if it's yeah. We're gonna make use of this fact that it's sorted. That will let us know that the one next to it, if there is a duplicate, then it'll show up next to it. So that's very key. Okay, so here's the problem from example one. What we're gonna do is we're gonna have 2 pointers. We're gonna have a current pointer, and we're gonna have a previous pointer. And in the code, I'm gonna write them out. All on this blackboard, I'm just going to do the initials so that it fits in here better. Okay. Okay, so we have our previous node and our current node. Now our previous node is currently pointing to null, so we would have to check to, in our code logic, we'd have to check to see if we're at the head of the list so that we don't say previous.val because that would be a null pointer error. We can eliminate that check by doing this special trick. So here's this one special trick that you can do with linked lists. And this trick is very helpful in a lot of linked list problems. So here it is. We're going to copy, or sorry, not copy. We're going to create a dummy node. And the value of this dummy node can be anything. I'm just going to say -1. It doesn't matter what the value is because we're not even going to use the value. What this dummy node allows us to do is to have that previous pointer be pointing to some node. So the previous pointer is no longer null now. And since the previous pointer is no longer null, now we don't have to have a special check to see if we're at the head of the list versus if we're not at the head of the list. Okay, so next what we're going to do is we're going to check to see if this current value is equal to this next current value. And if it's not, then what we'll do is we'll move these down. And then we check to see if this current value is equal to the next, and if it's not, then we move these down. Okay, let me write the code that we have done so far. So far we have said, while current is not equal to null and current.next is not equal to null, then if current.val is equal to current.next.val, do something. Otherwise, we move them down like we've been doing. Current equals current.next, previous equals previous.next. Okay, so now we're gonna, what do we do for this do something? Let's see what we do. So if current.val equals current.next.val, what we're gonna do is we're gonna move this down. And if there was more threes here, we'd keep on moving it down until the current.val does not equal the current.next.val. So here's how we do that. We need to do that with a loop. So we say, well, then we got to make sure that they're not null too as we're doing this. Okay, so then what's next? Well, next, what we're going to do is we're going to create. Next, here's the overall logic of what's going to happen. We're going to move this all the way down to here, and then we're going to delete all these nodes. And then this is going to move up. Okay, so we got to write the code to do that. Now, when we are see this here, we when we're deleting these nodes, we got to make sure we don't just like move this up here and we got to make sure we don't just move this up here and do something like this, because now we have a sublist and we have a memory leak. So we got to go and delete each one of these so that nothing points to these objects. And then if nothing points to these objects, then the garbage collector will clean it up. Okay, so we'll go ahead and write that code. So first what we need to do is we need some more pointers to help us to do all that work. So we're going to create a temp previous pointer that will point to the previous node. I'm going to call it TP. And then we also need a previous pointer that will point to the temp previous node. And then, okay, now we can say that the temp previous node or temp previous pointer is going to move up. Actually, let me write down what I've done so far here. So we have this temp previous pointer that points to that. We have this previous that points to the temp previous. I could just go like this. So I'll make it a little cleaner. Okay, and then now we're going to move this up. And then once we move that up, then we're going to move this all the way up here like that. And then this guy is going to move up here like that. Okay, so here's that code. Excuse me. Okay, now we got to go delete these nodes. That's where this TP and the previous pointer come into play. So what we're going to do is we're going to say as long as this TP does not equal this C, then we're going to go one by one and delete these. So and we're going to say that the previous will go to where the TP is. And then we're going to say that the TP is going to go to where the TP.next is. And then we're going to have our previous.next equal to null. So previous.next, which is this one right here, null, so that deletes that. So this previous is a local variable, and it'll go away pretty soon, and then this will be left with nothing pointing to it, and so the garbage collector will clean it up. Okay, so we loop back up to check to see if TP does not equal C. It does not equal C. So then the previous goes to where the TP is. And so nothing points to this now. So that gets deleted. And then the TP goes to TP.next. And then the previous.next is null. And then we check to see if the TP does not equal the C. It does equal the C. So then we loop back up. And when we loop back up, this goes away, that local variable. Nothing points to this anymore, so the garbage collector cleans it up. I'm going to move this down just so it looks better. Okay, so now we're checking to see if the C is not equal to null and the C.next is not equal to null, and is this value equal to that value? It is, so we move this forward as long as the value that it's pointing at does not equal the next value that it's pointing at. So this value does not equal that value, so it stops, and then now we have the TP goes to where the P is, and the previous goes to where the P is. And then the C, and then the this goes to where the C.next is pointing. And then this moves up. And then as long as the TP does not equal to C, then we iterate. So the previous goes to where the TP is. The TP goes to the next. Wait, hang on a second. TP.next, TP, we were at our previous, which is here, which is the TP, and then the TP.next. Okay, let me back up a little bit. Sorry, I needed to, let me back up just one. Okay, here we are. I skipped a step. So we're here currently. Now we're going to do this one. So and then now we're going to do this one here. Okay, and then now we're going to do this one here. And then this one. Okay, now we're in this while loop, and as long as the TP does not equal to C, then the previous will move out to where the TP is. And then the TP will go to the next one. And then the previous dot next will be null. And then we'll check to see if the TP does not equal to C, and they don't equal each other. So then the previous goes to where the TP is. And then nothing points to this now, so the garbage collector cleans it up. And then the TP moves to the TP.next. And then the previous.next is null. And then we check to see if the TP does not equal to C. They do equal each other, so that stops. Then we loop back around. This local variable goes away. Because nothing's pointing to this, the garbage collector cleans it up. I'm going to make this look better. Okay, so the now the check to see if the C does not equal to null and the C.next does not equal to null. Well, the C.next is null, so we stop this loop. And then the answer is this dummy.next. Or you could do the head, either one. I'm just going to do the dummy.next. You'll see in other problems there'll be where you're using dummy, then you'll use the dummy.next if you end up using the head. Sometimes you can just use your head pointer to reduce the number of pointers you're creating. Okay, so that's the problem. Let's go code it up. All right, so we'll go ahead, and we knew that we could be in a situation where head would be null, or let's see if we can make this a little bit bigger for you guys here. Or the head.next would be null. And if that's the case, there's nothing for us to do, so we just return the head. Then we create our dummy node, and that's pointing to the head. Then we create our previous node, and then we create our current node. We'll point that to the head, and then we're going to do our while check. And then we're going to check to see if the current node.val is equal to the current node.next.val. And if that's the case, then we're going to do that while loop. And in the while loop, we do this, and we do this. And then we're just moving the current node up. And that's the case. Okay, and then we had these other things. We had that temp previous node, which was our TP. That was pointing to the previous node. And then we also have the previous node, which was our PP. And that points to the previous node. And then we said temp previous node set to the temp previous node.next, and then the previous node.next was equal to the current node.next, and then our current node was pointing to our current node.next, and then we deleted our nodes as long as that TP did not equal the current node, then we said the previous node equals the temp previous node, and the temp previous node equals the temp previous node dot next, and then the previous node dot next was null. Okay, and then we said that if they weren't equal to each other, then the else case was just to move the current and the previous up. So we had the current node equals the current node dot next. The previous node equals the previous node dot next. And then after all this, we just return the dummy node dot next. Okay. All right, so that passed. That's good. All right, next. Oh, and by the way, this is the exact same code that got 0% last time when I ran it just a second ago, and it beat 100% of the users. So beats 100% of the users. So it's just like sometimes Leetcode is slow, I guess, on that day. But anyway, so this is linear. Now what we're gonna do is we're gonna go to Python and we'll write the Python code. All right, so that's true. And then if the current node.val equals the current node.next.val, then we do this check here. And we do this check here. And then we say the current node equals the current node.next. And then the temp previous node is going to equal the previous node. And then the previous node is going to equal the previous node. And then the temp previous node, let's see, temp previous node will equal the temp previous node dot next, and the previous node dot next will equal the current node dot next, and then the current node equals the current node dot next, and then while the temp previous node does not equal the current node, then we'll say that the previous node, temp previous node, temp previous node equals the temp previous node dot next, previous node dot next equals null, none. Okay, and then else, if this wasn't true, then we'll move the pointers forward. And then I'm going to return the dummy node.next. Okay. Okay, great. So that passed. So let me zoom out a little bit so you can see that. Okay. All right. Well, if you liked this video, please subscribe to the channel, because when you subscribe to the channel, it lets me know that you want me to make more of these videos, and I'll go ahead and make more of them. This video is part of the Two Pointers playlist. So in the video description, you can find the link to the Two Pointers playlist, and it's good to start from the beginning and go down through the end of these videos, because they build on top of each other. Um, they get increasingly more difficult as you watch more videos, and you'll see the progression better if you start from the beginning and go to the end. All right, thanks. Well, have a good day. Bye.